Good day, guys. So, by today, we'll be discussing about six-state protocol. So, again, it comes under the QKD quantum key distribution. So, we have started this QKD with looking into BB84, then followed by we have seen E91, then we have seen BBM92. Hope you guys remember, right? So these two are entangled photon, right? And this is the classical first protocol used in QKD. So just to recap, in this QKD, key is transacted over quantum channel. Just remember this. Here in quantum cryptography, we are not making the quantum channel, right? We are not making the data to be transferred, right? It's not data. We are making the quantum key to be transacted between the Alice and Bob, and for that we are deriving all those protocol, all those BB84, E91, BBM92. In that way, now we are stepping into the sixth state, right? And the term itself state that it uses six different states, right, for QKD process, whereas in the earlier BB84, right, even E91 or even BBM92 all uses, right, it's a, you can say, fourth state, right? We have just used the two bases, namely Z base and X base, we can say bases, right? So just to recall once again, usually the Bloch sphere, it's a geometric representation of the qubit where we will be having this, right? Hope you remember. So this is Z basis, this is X, and this is Y. Hope you remember. And this is represented by a rectilinear, and this is by diagonal, and this one is by circular. So now in this sixth state protocol, we are going to use all those Z, then X and Y. So this we already know, it's a rectilinear, which uses horizontal and vertical polarization. This X basis uses the diagonal, which uses 35 degree and 135 degree polarization, whereas this Y uses circular, which is usually represented by right circular, right, and left circular. So it's simple that six state protocol using three bases will result six different states, So that in fact makes the eavesdropping detection to be in a higher fashion. So it's simple to understand, right? So when we use the two bases, we have the probability of 1 by 2, whereas when we use the, we can say that, right, three bases, 1 by 3. So the probability of the eavesdropping, right, becomes easier for detection, or we can even say the guessing became comparatively less with the two bases when we go for the three bases. Now we still dig deeper that how these bases are classified, right? So bases, so we do have is it, so and again basis is it. So here we have the rectilinear, which is in fact represented by vertical polarization and horizontal polarization, and this could be a bit 0, this could be a bit 1, and similarly we go for x basis, and this diagonal, whereas one could be 35 degree and another could be 135 degree, and again this 35 could say 0 and 135 could say 1. Similarly we go for y, this is circular fashion. So here we can say R and L, this R is 0 and L is 1. So this is how we can easily perceive 0, 1 in Z basis, 0, 1 in X basis, 0, 1 in Y basis. So altogether we do have 6 states, and hence the entire process is said to be 6-state protocol. So now the probability becoming 1 by 3, so which we have a QBR, quantum bits error rate, to be higher, and that ensure eavesdropping in easier way than the other protocol. Alright, so now we go for an example. So for instance, if Alice is using a basis Z and he is transmitting a bit 0, right, and this side we have the Bob basis. Bob is using a X basis, so it became a random. So now Alice is using a X basis, and right, it may be of any bit 1, and Bob is also using the X basis. Now it became the same bit. Now Alice is using a Y basis, and the bit is like 1, and the Bob basis is also Y, then the bit will become a 1. So again, if Alice is using an Z and the bit is 0 and Bob is using Z, the bit is 0, right? So here same basis, so here Z X, it became a random, so discard it. Here X, right? So bases are correct, so we are keeping it. Y, the bases are correct, we are keeping it. Z, we are keep the bases are correct, so we are keeping it. So QBR, so total mismatch by total comparison. So this is how we usually find this QBR percentage. And guys, you remember it should be always less than 11 percentage in order to keep the key or about the communication. So the only look, all the comparison, all the QBR, what we are looking for less than 11 percentage, or if you go for this E91, we go for well inequality, we used to check na S, so it could be S less than or 2. So all this, right, would be remains the same, but this SS 6 state protocol states that actually 6 states are invoked in order for higher probability finding of eavesdropping. So it is simple, right? So easy to proceed. The only thing you have to remember that how all those bases are represented, and how we are trying to say that probability is 1 by 3 instead of 1 by 2. Just understand this. So it's simple, easy to grasp.